Hello everyone, my name is Mohammed Hassan Sayed, and today I'd like to talk about my wireless ECG device project. Every year it is reported that about 17.9 million people die because of cardiovascular diseases. So this gives rise to the importance of ECGs. An electrocardiogram can be used to record the depolarization and repolarization of the heart, which could therefore be used to detect irregularities in one's heart. Typically, if someone thinks that there's something wrong with their heart, they would go to the hospital, and the doctor would then do a 12-lead ECG test, and then if something were to happen to them during the test, they would say they would be able to associate that irregularity with a certain disease. But if something does not happen during the test, it would not be identified. So this gives rise to the demand of wireless ECGs. That's one place where wireless ECG could benefit us. You could take an ECG reading at the ease of your home. A second reason why wireless ECGs could be beneficial is if you'd like to do an ECG reading while exercising. So here is the ECG signal, and we can see here that several important parameters are listed here for an ECG signal. For example, we have these intervals and the QRS complex and segments. Any variations in these segments or intervals could actually be diagnosed with a certain heart disease. So if a heart is beating, it would look something like this. This is how the ECG would plot out. And in my case, since I'm using a heart rate monitor, a single lead would connect to 3 electrodes, and if the electrodes are connected in this manner, an ECG would be generated this way. The 3 electrodes would be connected at these locations. 3 electrodes are connected to this single lead, and this lead would then be connected to the heart rate monitor. So the lead is connected to the heart rate monitor, which is the AD8232, which is then connected to a Wi-Fi module right here, which through a potential divider, a 100 ohm and a 200 ohm resistor, and this Wi-Fi module sends data over to a database, and that database sends data to actually this Android application would then read data from the database, which I'll show in just a moment. So this is powered through a lithium-ion battery, which is right there, and that's the whole point of making this wireless. So if I were to take my ECG reading just now, I just go to the app right here, and then go here, and then here. So I'll just move this to landscape, and here we can see our ECG reading. So we can see that we have the beats per minute as well. So as you can see, it keeps updating. I'm gonna move this away for now, and there we go. That's my ECG reading. All right, to make sure that this actually works, I'm going to remove this lead from here. So now they should go to 0 in just a moment. The reason why it takes a little bit of time is because I'm sending data over to the database or a delay. So I'm gathering a bunch of data, and then I'll write to the database, and then I'll gather a bunch of data and then write to a database. So that's why there's a small delay. So if I connect this back, we should see it give an ECG reading. There we go. It's back to normal again. So here we go. That's my ECG reading. Compare how my wireless ECG project compares with the actual ECG device that's on the market. So the Apple Watch actually has an ECG thing that you can use. It has LEDs on 2 points, so the one right below the wrist and the one on the index fingers. If I use this, I can actually measure my ECG signal. So now let's compare how it would show up with the ECG that my project uses. If you put this side by side, we can see that the results are very similar. And I think the Apple Watch is also FDA approved, so we can see that my project works really well side by side. One unfortunate thing about the Apple Watch is that you can't have live data on your phone while you're recording. You can have you can send this data to the PDF on your phone. And here's the device that's working. You can see that it's blinking, and that's the Wi-Fi module. Now let's discuss how I'm implementing all of this. So it's in 3 steps. I have the hardware, so the Arduino board. It's not an Arduino board, but a microcontroller which uses an Arduino IDE to execute the code. The heart rate monitor, which writes data to the database, and then the Android application reads data from the database, and then plots the graph, the ECG graph. First step, I'm using the Arduino to upload the code to the Featherhusa with ESP8266 Wi-Fi module. You can see here that I'm connecting to the Wi-Fi in the first step, and then at this point I'm making the connection with Firebase, and then here's just a for loop to gather data from the heart rate monitor. I'll gather 250 values and then store it in an array, and then write the whole array to Firebase. So this would be uploaded to the microcontroller, and then the next step would be the Firebase database. So over here I have the Firebase database console. So if I go to my project Arduino ECG, I can see some good analytics here. So the thing that's concerning to me is I'll go to the real-time database, and we can actually see things being updated here. So if I give it a moment, you'll see that the values keep changing at this point. There we go. We can see that it just changed, and then it will change very soon again. There we go. And this keeps changing. So you can see that it's actually writing to the database. Now the next step would be to write the application. So I've written this whole application myself. I've used the SciChart application that's available on trial basis online. I've used their template, but connecting to Firebase and retrieving data was all written by me. So you can see that this whole thing is, a lot of this was already pre-made, and you can see there are a bunch of files here. So the thing that I edited was within fragments. I went into ECG monitor fragment, that's this file, and within this, now I'll have to connect to the Firebase database. So to do that, you can see that at this point, I've defined, there we go, Firebase database, database, and the database reference. And then in this array is where I'm storing all the data that I read from there. So if I scroll down, you'll see that I have here, I'm getting the instance, and then this is the test/int. That's where it is in Firebase. If I just go back, you can see that it's in test and then int. So that's how it would be read. So we can see Arduino test and then int. So now if you go back here, this is just basically, so read.ecg is the method where it's reading. So if I go to this method, it's down here. At this point, it changes on data change. It will get the whole array from Firebase. So it will detect when data changes, and then it will read the whole thing and then save it in the value. So it does this on this iteration. So every time it finishes writing a set of values to the app, then it will execute this method. So that's pretty much what I've done, and at this point I'm averaging the values for BPM. BPM is beats per minute. I wanted to display a text box showing me how frequent, or the frequency of the heart rate of the peaks. So I'm averaging the values, and it doesn't change as often. So here we have it. This is how I have it working. For more details, please refer to the report. Thanks.